Okay, so this is our third lesson in our unit on transformations, and we're going to focus on rotations in this lesson. So our essential understanding is that students, or our learning goal, is that students will understand, use, and construct rotations of plane figures. The specific success criteria for this lesson is we want to be able to identify a transformation that is a rotation. We want to be able to locate the center of rotation. And find image points that have been rotated. We want to be able to use rotations to construct regular polygons. And we're also going to then use some geometric software to construct rotations. So we're going to address the first three in the video here, and then we'll use Geometry Sketchpad to do the last success criteria in class. Okay, so what is a rotation? Well, it's a turn, right? So as rotation is comprised of three things. The first is direction. We can either rotate something clockwise or we can rotate it counterclockwise. But what we need to know is how much we rotate the figure, and we call that the angle of rotation. That tells me how much does my figure turn. And then there's also a center of rotation. I think my figure's in the way. Center of rotation is the place that's like the beginning place. It tells me where to rotate from. Okay, and we'll see an example of a center rotation in a little bit here. If we were to look at this point S, and if we rotated point S here about point R, and we rotated it X degrees, then it would lead us to the location that is S prime, the image point. And if that happened, then the segment that connected R to S would be congruent to the segment that connected R to S prime. And the angle that we created, angle S, R, S prime, would be exactly equal to X degrees if my rotation were X degrees. So we'll look at a couple specific examples here in a second. A couple properties of rotation include that a rotation is an isometry, so it's not going to change the size of anything, and it also does not change orientation. Sometimes it can be difficult to detect if something is a reflection or a rotation, and if it's reversed the orientation, then it's probably a reflection. If the orientation isn't changed, then it's probably a rotation. So let's look at a couple examples. A real simple one is rotating something 180 degrees. 180 degrees almost looks like a flip, but it's not going to be, but it's going to be moved in a little bit, slightly different direction. So if we want to rotate this figure about point T, we want to visualize or put point T in here. So I'm going to get my pen and let's put in a point right here. So here's point T. And then I'm going to take my figure and do this. What would happen is my figure would turn upside down, but the point that was point T is going to still be connected to point T. So it's as if my figure made a big semicircle. So R swung around and went like this. S swings around and ends up there, right? So that's what happens when we look at a rotation. If we wanted to label my points, this point would be T prime, this point would be S prime, and this point would be R prime. So in this case, since my center of rotation was one of the original points, T and T prime are the same point. All right, let's look at another example of a rotation. Let's find the angle of rotation about point E that maps the pre-image to the image. How can we figure out what the angle of rotation is if I've just been given the two figures? Well, what you want to do is draw two rays that connect the center of rotation, so that would be point E, to the corresponding points on the pre-image and image. So we want to choose two corresponding points. So for example, we might choose point A, and then A prime is down here. So those are my two corresponding points. We want to draw two rays that connect the center of rotation to, and that go through those corresponding points. So here's one ray. That would be ray EA. And then I want to draw the ray that goes from that same center to its corresponding image point, A prime. Then what I want to do is measure that angle of rotation using a protractor, because I can approximate it, but if I want to know exactly how big it is, we need to use a protractor to do it. So we'll get my protractor tool out, and remember what you want to do is put the vertex right on that T, and then we're going to spin this guy so that one of the sides lines up with the 0 line right here. So in this case, I'm going to use the outside scale because that starts at my 0. And measuring this angle, it looks like 0, 10, 20, 30, 40, 50, 60, 70, 90. Looks like my angle is about 105 degrees. So in this case, I'll move my protractor out of the way. My angle of rotation is 105 degrees. So we'll put that in there, but you got to know that in order to find it, you have to use a protractor to measure the rays that connect the center to two corresponding sides. Okay, let's look at another example. Let's draw the image of triangle ABC under a rotation of 100 degrees about point D. Now drawing a rotation is similar to finding the angle of rotation, but it's a little bit more difficult because you have to draw a lot of lines in your plane. So I'm going to get my ray tool here. I'm going to make it real small, and I'm going to use colors to help me find the corresponding rays that go together. Okay, so first I'm going to draw a ray that goes through, that starts at D and goes through point A. Now I want my rotation to be 100 degrees, so I'm going to use my protractor again, and maybe I'll make it a little bit smaller here so we can tell. There we go, a little bit smaller. Line it up so my center is on my center of rotation. We're going to spin it around now so my 0 line lines up with that ray that goes through DA, ray DA, and then we're going to mark where 100 degrees was. Okay, so we can see that 100 degrees is on, we're going to use the inside scale because that starts at the 0. So now we want to draw a ray that goes right through 100 degrees. Okay, I'm going to move my protractor out of the way. And then what we want to do is measure the distance that goes from D to A. So now we have to use our compass tool. So we're going to do this, flip that over there, open up my compass. There we go. Maybe rotate it a little bit down, make sure that marking is correct. So that's the right distance. Now we're going to go over to our red line and mark a point right there. That's actually going to be my new, or my image point, A prime. And this one's a little bit weird because it happens to be kind of right on top of almost exactly where we see point C. All right, so we're going to do this again. I'm going to choose a different color. I think it's going to really help you to watch the whole process here. And I'm going to draw a ray that goes from D through point B. All right, get my protractor again, line it up, put that on the vertex, rotate it so that my side aligns with DB. And now we're going to draw a ray that's 100 degrees again from D. So there's my 100-degree line. So there's my ray. Oops. I move my compass out of the way. I get my protractor again, and what I want to do now is mark the distance from D to B. So I need to open my compass a little bit more. Whoops, there we go. And we'll mark that length of B. Now we'll go over here, and let's see if it'll let me choose a different color. Blue, black, blue, so that goes that. And we'll mark the point that is B. Okay, we're almost finished. We got 2 points of our transformed triangle. We got to get the last point, and that's going to be C prime. So again, we'll get our ray tool. We'll go in, let's make this one purple. So we're going to draw a ray from D. I want that to be a little bit thinner so it doesn't take up too much of the space. From D through C, get our protractor. We want to mark that angle of rotation. So line it up exactly, there we go, there. And line my protractor up with point C. Now we're going to draw our ray. That's a 100-degree angle from DC. So 10, 20, 30, 40, there's my 100 degrees. Draw a nice big ray. Now we can get our protractor completely out of the way. We don't need it anymore. Oops. Get that protractor out of the way. And we'll use our compass tool to mark the length of side DC. So get the point there, close this up a little bit, take this to our purple line, mark that. Excellent. Okay, so now let's label those points that we just put in there. This was B prime, and this one was C prime. Okay, so look at all of those points that we have, B prime, C prime. Now let's create our new triangle. A prime was right here where the red and green intersected. B prime was here. C prime was here. And so we need to connect those 3 points. Now I know that there's a lot going on here. But what I want you to visualize is triangle ABC, which was here. Can you see how that's been rotated 100 degrees about point D? And these are hard to draw by hand, so you're going to practice doing that in class. All right, so I want to show you one last thing. Whoops, not that yet. I want to talk about how we can construct a regular polygon using a rotation. And I'm going to use the example of a pentagon to help illustrate this. And then you guys are going to be constructing some of the regular polygons in class using using Sketchpad. Okay, so we know that we can use a rotation to construct any regular polygon. So I want you to think about a pentagon. A pentagon has 5 sides, and the sum of the angles adds to 540, right? We know that because n minus 2 times 180 would be 5 minus 2, which is 3. 3 times 180 is 540. But since it's regular, we know all of the interior angles are exactly the same size, right? So each of these big angles would be 540 divided by 5, which is 108. Okay, so each of those big angles that I just marked is 108 degrees. But if I draw in what we call the radii, all of these are really radiuses. It's almost like this is a circle that go from the center to each vertex. If I draw all of those in, what I would be doing is cutting that 108 degree angle exactly in half. So 108 divided by 2 is 54. So I got my little 54s right here. That means this angle is 54 degrees, and that means that this angle over here is 54 degrees. If I know both of these angles are 54 degrees, 54 and 54, of course, is 108, and 180 minus 108 is 72. What I'm doing is looking at this triangle right here. I'm looking at that triangle and using the fact that the angles add up to 180 to get that central angle. Okay, so we know that this central angle here is 72 degrees. So what I could do is I could take this segment right here. If I rotated that segment 72 degrees, I would get this segment. If I rotated it 72 degrees again, I would get this one. Rotate it again, I get this one. Rotate it again, I get this one. And I know my segments have disappeared, but if they were all still there, then you would have this kind of star shape, right? Then all you have to do is connect the endpoints and you'd have your regular polygon. So we can construct a regular polygon, or in this case a regular pentagon, by rotating a segment 72 degrees, and we're going to make that rotation 5 times. Now let me show you that rotation in Sketchpad. So let's say that we have our diagram here. We've got our segment, AB. I'm going to make A the center of rotation. Now I'm going to select the entire segment and I am going to rotate it 72 degrees. Okay, so we did that. And then I'm going to do it again. I'm going to rotate it 72 degrees again. I'm going to rotate it another 72 degrees. And I'm going to take that segment and rotate it 72 more degrees. So now we have that star shape that I was talking about. And if we connect the endpoints of all of those segments, you can see we have what appears to be a regular pentagon. Now what's cool about this is because I constructed this using a rotation, it doesn't matter where I move point B, my pentagon stays regular, and it's going to increase or decrease based on how long segment AB was. All right, so that's everything that you need to know about rotations. We'll practice this in class, but I want you to write down some of the important things about rotation. That should include the center of rotation, the angle of rotation, whether or not it's an isometry, whether or not the orientation stays the same, and maybe some tips to help you remember how to find the angle of rotation or how to construct a rotation.